So today's presentation is on lecture is on rating and overloading of power transformer. This is part 1 actually. So tomorrow also we will have one more class and then finish the topic actually. So here today we will study about what are the ratings and what is overloading and what is the effect of overloading. Rating, so it is defined as it is the scheduled operating conditions for which operation of the equipment can be expected for a time period of its nominal life. It's around 20 to 30 years without any hazard. So, what are the conditions? Scheduled operating conditions for which operation of the equipment, in this case, transformer, can be expected for a time period of its nominal life. So 20 to 30 years, if it is operated under that conditions, rated conditions, it is expected to survive for its nominal life. So these conditions are known as ratings of transformer in this case, or any power equipment. But on what does this rating depend? Whether V or I or what else, or power factor. So the rating of the transformer depends upon the temperature rise actually. So we will see soon what is the effect of temperature under, or indirectly on losses. Temperature means that will be due to losses only. And losses depend upon both V and I. Hence, the rating of the transformer depends upon V into I, which is also termed as VI rating or volt ampere rating. Volt amperes or kilovolt amperes or megavolt amperes are used for ratings. Apart from this, voltage rating will also be given. But it does not depend on the power factor because the losses depend on I, not I cos theta under. So that's why V into I is decided as the rating, volt ampere rating. So this is about rating. Then can we cross this rating? What happens if there is a rated conditions, rated volt amperes and rated voltage and rated current? So if one crosses beyond the rated conditions, what will happen? Normally, overloading means what? Whether it is exceeding voltage or exceeding current. What is your opinion?
Sir, it's exceeding current.
Yeah, exceeding current. It is not exceeding voltage. So overloading means I is increasing. Right. If I increases, losses will increase and consequent effects will be there. Temperature will rise and therefore what is that effect? What is going to happen? That we have to understand now. Overloading and its effects. Basically, overloading is limited by these three conditions here, whatever is given here. See, voltage drop on equipment. If we overload a transformer or any power equipment for that matter, what will happen? If I increases, then what will happen? The voltage, the voltage will eventually drop because the leakage reactance will cause drop. So I into X or I into Z. So leakage impedance if you consider, I into Z will be the drop on the line. So this will ultimately cause the voltage drop. It cannot be too much, right? So there should be, the voltage should be within certain limits. Voltage regulation, whatever, what it is called. So therefore, the overloading is limited by voltage drop. We cannot have excessive current, which will cause more voltage drop on the line. And second item is the cost of the losses. If you increase I, actually the transformer or equipment is designed for a particular value of current. It means it is designed for particular losses. So if you increase I, suddenly the conductor diameter is not going to increase. So I square R losses will obviously increase. So this increases the cost or losses in the equipment. And the other one, the last one, the aging effect. What is the effect? Okay, losses will increase even if that can be tolerated, even if the first two can be tolerated. Can you tolerate the third one? Third one is even more severe actually. Aging effect. What is the aging effect? Okay, if you have overloaded a transformer, so continuously heat is developed, but its designed temperature is this much, and then your actual temperature under present load conditions increased. Then due to the temperature rise, the aging will be more, as we can see soon what will happen and all. So this is the third condition which will limit the overloading. So overloading is limited by these three factors. Now let us see effect of overloading a little bit detailed. So what will be the electrical stress due to overloading? What do you think?
High stress on an insulation, sir.
Electrical stress means electrical field related issues you have to talk. Whether there
Okay,
will
sir.
be increase in electric field in any part of the transformer, because when you design a transformer you have to take care what are the electric fields inside the transformer, and with that electric field what is the effect of aging or effect of breakdown or whatever it is. So the electric field design has to be taken care inside the transformer, and at the edges or where the end points are joints where you are joining to the leads to the bushings. So there we should not it should not happen that the electric stress increases due to overloading. But will it happen actually? When we overload the transformer, are we going to increase the electrical stress, means electric field inside the transformer?
No, sir, because I think voltage will be same.
Yeah, by overloading we mean only current is increasing. Effectively voltage remains more or less same. Of course some dip will be there, but if you neglect that dip, so there is no huge change in the electric field. Okay, so electric field is not going to increase at any part of the transformer, inside the transformer. Therefore, there is no change in electric stress. So electrical stress will not occur, or rise in electrical stress will not occur due to overloading. Then let us go to magnetic stress. What will happen to magnetic stress? So this unfortunately in a live class we would have enjoyed a little bit more, but I have to put it on this, and then otherwise it is not complete. So I expect that you answer by thinking.
Sir, due to increase of current, flux will increase.
Due to increase in current, flux will increase.
Increase the magnetic
correct?
stress. That will increase the magnetic stress on transformer.
Is that correct in a transformer? Will flux increase with increasing current?
Flux will remain constant because on the secondary side, if suppose the current is increasing, then on the primary side automatically the current will increase and that will maintain the flux.
Yeah, equal and opposite fluxes will be generated, right? So only that magnetizing flux will be there always in the transformer. The main flux, whatever main flux it is called, magnetizing flux, that remains constant. Due to secondary current, always there will be primary ampere turns which will be countering that secondary flux, and effectively that flux gets cancelled. Therefore, always only the main flux, means magnetizing flux only will remain in the transformer. Okay, this you must know in lower classes. So transformer, please, we will be dealing with a little bit higher level. So the fundamentals, just please revise again once more. Go back to your BTech books and then revise. So this I assume that you already know this thing. So that is where the difference may happen. Therefore, what is main flux and how the fluxes get cancelled in the transformer. So this you please try to revise again. So, but leakage flux and hence stray losses increase. That's what leakage flux. What is leakage flux?
Flux that just link himself, sir, itself.
Flux
that link itself, sir.
Flux link itself means what? Flux cannot link itself.
Sir, if there is a closed path, then the flux will not go to the closed path. It will leak to the closed path and come to that.
All flux lines will be closed paths only, irrespective of wherever they are.
Sir, leakage flux depends on the permeability of a core. I mean, if we are taking the core of an infinite permeability, then all the flux will link only the transformer, the core of the transformer.
Oh.
Sir, I think the flux that does not travel through the core but travels through the air or the insulating medium, that is the leakage flux, because that flux does not find a path to complete itself in the core. It forms a closed loop path in the insulation. That has to happen, sir, because insulation has also some type of conductivity, because it's not a perfect insulator.
Okay, but if somebody is asking for permission, I don't know, some message has popped up. Somebody is asking for permission. If he has any problem, he may give in WhatsApp. Just send a message to him. If anyone wants permission to join, why not use institute mail ID? If institute mail ID is used, the access is without any permission, he can come. Anyone. Okay, so let us go back to what is leakage flux and all. So, leakage flux, right? We are talking about leakage flux. So, various students have given various definitions close to what it is, but it is not accurate actually. There is some.
Sir, the flux that does not link with both the windings.
That should be the definition. So it may leak through the core, but it may still link the both windings sometimes. So in that case, you cannot call it leakage, right? So if the flux links only one of the windings, and if it does not link the other winding, that flux is called a leakage flux, right? Now, the question is, I said that main flux will remain same. Main flux means the magnetizing flux. That will remain same. Whether leakage flux will also remain same or not. If not, why? And if it is, why?
But there's nothing to oppose the leakage flux. There's nothing to oppose the leakage flux as we had with the main flux.
So it will remain this. It will change. Leakage flux will change.
Can you please repeat? Your voice was not clear.
Okay. So the leakage flux has nothing to has no opposing force.
No, it's not force. So let us be careful in, Just I am getting a phone call. Just I will come back. Yeah, so we were discussing.
Sir, can I answer, sir? I have thought of something. So
Yeah.
yeah, sir. So actually, the total flux that is the perpendicular addition of two vector addition of two flux, leakage flux and the main flux. Because because that is the basic. So I'm just saying that it's perpendicular addition, and because the main flux remains same when the current increases, the secondary side also the current will increase because the main flux increases, but the total flux. I mean, sir, the leakage flux has also to increase to keep the total flux same. That's what I'm saying.
No, that is wrong.
Sir,
It is not, due to the leakage flux, the main flux is getting reduced. No, it's not that. Main
Sir,
flux is, yeah.
Sir, leakage flux is not linking to both the windings. So increment in one winding, then other winding cannot sense its increments. So there will be no counter effect to this. That's why it will keep on increasing.
Yes. So that is true. So since the main flux is linking both the windings, and one winding is primary and another winding is secondary, which have currents in opposing direction, in the sense they are creating flux in the opposing direction. So counter flux will be there in case of main flux. So therefore, always, apart from, magnetizing flux, whatever comes in due to secondary winding, that will be countered by the primary winding, and main flux remains same. But this does not happen with the leakage flux. Leakage flux is the flux which is linking the primary winding alone or the secondary winding alone, which does not link the other winding. So other winding cannot produce a flux that can counter this flux. So therefore, leakage flux of both the windings will increase. So this will cause stray losses. Stray losses means whenever leakage flux increases, so it will be, of course, part of this has to go through the core only, and part of this will go through the air, of course, but it has to go through the core for some part. Wherever it goes, there it will cause the eddy current and hysteresis losses. These losses are known as stray losses. Stray losses means that will happen due to leakage flux. Okay. So when leakage flux, when current increases, or when you are overloading the transformer, so the stray losses will increase, but main flux remains same. The stray losses are not that much actually. So therefore, this is the effect is minimal, we can consider. And then comes the mechanical stress. Mechanical stress. Where do you think the mechanical stresses will be there in the transformer? How do they come into picture?
Sir, it is between the windings because when the current is flowing in the same direction, it causes opposing force.
Between the windings.
Yes, sir. Like the winding which is wound on the primary and secondary. So between each turn of the winding, there will be mechanical force because current is flowing in the same direction. That's why.
Yeah. So whenever their current carrying conductors are nearby, always there will be force between them, either attractive or repulsive force will be there. So this force it depends upon the current value actually. So this force exists in the transformer between the turns as well as between the windings also. Okay. It's not only limited to the turns, but it is between the windings also, primary and secondary windings it will be there. But also within the winding also, between different turns, there will be mechanical stress. So this stress, what is going to happen if load increases? And this stress is proportional to what?
Sir, I square. The I1 into I2, both the currents will be same, so I square.
It will be I square. Of course, in the primary and secondary case, that is a little bit different. But I square, it is proportional to I square, you can assume. So, the windings, but if it is proportional to I square, then if overloading happens, so you can expect very high increase in the mechanical stress. But the transformer actually is designed for short circuit currents. Short circuit currents means completely the there is a short circuit on line, so the impedance will be very small. You can 0.04 per unit to 0.15 per unit, you can say. So this will lead to around 6 to 25 times of I rated current, short circuit current. So a little bit increase due to I square due to overloading. That does not cause severe effect due to mechanical stress. Therefore, overload mechanical stress has no significant effect because short circuit effect is even more. It is designed for that purpose. So therefore, this is not a significant effect in the transformer. Then let us see what else is there. What else will be there other than these stresses?
Temperature.
Yeah. So next is thermal stress or temperature effect. So one important observation, solid or liquid undergo a chemical alteration with time under the influence of heat, as well as other agents such as oxygen, moisture, etc. of course. But effect of heat is there on chemical alteration, chemical say dissociation or degradation. But out of the solid or liquid, we don't have much problem because oil can be changed in a particular schedule. So you can, or whenever you feel that oil has deteriorated, that can be replaced. It's not a problem. But solid insulation, which is supporting the windings or winding structures, is not easy to replace. So you have to rewind, that's it. So this is difficult to be replaced. Two main qualities of solid insulation are, one is its dielectric strength, other is its mechanical strength. So what will happen to the dielectric strength with temperature? What will happen to the mechanical strength to the temperature? This we need to understand. Did you understand first why dielectric strength is needed for solid insulation and why mechanical strength is needed? Was it audible? Hello?
Yes, sir, you are audible.
Yeah, why dielectric strength is needed for insulation, solid insulation, and why mechanical strength is needed for solid insulation?
Sir, dielectric strength is required because in case of voltage rise, sudden voltage rise, so it can withstand that. It does not melt away with sudden voltage rise or something.
Yeah,
like
even
voltage spike.
normal voltage also it has to bear, right? Normal voltage also it has to bear. So some dielectric strength is always needed.
Yeah.
It cannot puncture, right? So we need dielectric strength. But why do we need mechanical strength?
The alternating current would also twist and turn the dipoles.
Yeah, there will be actually, of course, the structure need to be supported. The winding structure need to be supported, no doubt about it. But apart from this, even under normal conditions, the current will be there, right? So always there will be force of attraction or repulsion between the winding turns and then windings. So therefore, the structure, the dielectric which is supporting, the solid insulation only will be supporting this one. That must have adequate mechanical strength also. So these two qualities are required for solid insulation. So what will happen under thermal stress to these qualities is of interest for us. We should understand that. Now the dielectric strength of insulation when aged in oil remains high until it reaches a certain point when it falls very rapidly. So this is what is observed until now. The dielectric strength of insulation when aged in oil remains high until it reaches a certain point. So this is how the characteristic will be. So, but where it drops suddenly. So this what is the phenomena. Breakdown strength BDS versus time. When a paper or press board is immersed in oil, it behaves like this, the dielectric strength. So what happened in examination of the insulation at this point shows that its mechanical strength is practically zero at this point. At this point where the dielectric strength suddenly falls, it was observed that its mechanical strength is practically zero. In other words, the material is actually quite brittle and also carbonized. So oxidation took place and then the material has carbonized. So dielectric strength, therefore, it alone cannot always be depended on to judge the effect of temperature on insulating material immersed in oil. So this is one problem. We cannot rely on breakdown strength or dielectric strength alone to judge the effect of temperature because it has already lost mechanical strength. So the breakdown occurs suddenly here. Suddenly it appears that the breakdown strength is decreasing. So that does not mean that the condition is good even before at some instant. There also it must have been damaged internally, but the breakdown didn't occur for some reason. That we will see what is the reason. But there are several means of determining the effect of temperature and physical condition of the insulation are available, such as folding it, tearing it, stretching, burst, or tensile strength. Tensile strength means elongation, or bending it under. So these mechanical properties will give us the physical condition of the insulation. By folding test, the life of insulation is very short. So if for example, this is what is physical observation, experimental observation. So if you go by folding test, so the life means the lifetime of the insulation, when even if you fold it should not break, then only it is okay kind of thing. So it breaks soon, so you will be estimating the life as very short, but actually it can still survive in life, and the life is longest when judged by tensile strength test. So if you use tensile strength test, the life will be longer, and if you use just simple folding test, the life will be shorter. These are mechanical testing procedures actually. Tensile strength was used in the tests reported because it is more practical, it is also simple, and more importantly, it is reproducible. See, whenever you report some results, actually the results, unless they are reproducible, they have no meaning. Suppose you use a folding test, one sample breaks after, say after aging for 1 minute, another sample breaks, for after 1 year, then it is not so reliable test, right? So say we need reproducible results. if it breaks, say, after 1 year, it should break for another sample also, maybe 1 year, 1 month, or less than that, or say 11 months, something like that. They should be in an order actually. So that's what is required from any test. So among these tests, tensile strength was reported frequently due to this reason. For class A insulation, class A insulation means paper or press board, etc. I will show you the insulation categories also, classes also in the next slide. So this for this material, so reproducible practical results can be obtained using tensile strength. But for class B insulation used in dry type transformer, tensile strength cannot be used since the basic insulation is glass fiber or asbestos or other material in which mechanical strength is not affected by the temperature. So for these class B insulation, we cannot use the tensile strength test. Alternately, what is done here is for class B insulation, dielectric strength or insulation resistance and partial discharges. That I will explain you that later, or otherwise now itself. Dielectric strength or insulation resistance and PD have to be used as for assessing the life of the insulation. So class B insulation means this glass fiber or asbestos or such materials which are used in dry type transformer. So among these, dielectric strength, dielectric strength is simply electric field at breakdown. EBD or EBDS breakdown strength it is written. So simply maximum electric field at breakdown is dielectric strength. Insulation resistance. Why insulation resistance is used? Actually, it indicates the losses in the dielectric material. Therefore, the insulation resistance also gives an indication. If the resistance increases, then obviously the material is becoming better, right? But it won't happen. If the resistance decreases, the insulation strength goes down, or it is becoming like a conductor. So of course, to become actual conductor, it takes a lot of time, but its resistance is decreasing means the conducting nature is coming. The actual ideal dielectrics are expected to be insulating. There should be, the resistance should be ideally infinite actually. Our conductivity should be ideally 0. So this resistance is another parameter which can give us or indicate the level or condition of the insulation at any given point of time. And third one is partial discharges. This is another aspect actually. Within the insulation, solid insulation, always there may be some voids actually like this. Voids means, air gaps or gaps filled with some gas during the manufacturing of the equipment such as epoxy, glass fiber or asbestos materials. These gaps actually will break before the solid insulation actually. The breakdown strength of this air is less than solid. So these gaps will frequently break down inside the void. Okay, this void. So inside the void, these frequent breakdowns will happen. For example, on a sinusoidal curve of input voltage. So at several points, there may be some discharges like this. These discharges will occur due to discharges within these voids, which are known as partial discharges. Okay, we will cover these partial discharges, in fact, in next semester in much more detail. For the time being, this much information is enough for you. So these discharges, measuring the charge in these discharges will also indicate the current status of the insulation material. Over the period of aging, actually, these discharges will become more and more because of, increase in size of this void by carbonization of the layers. over a period of time, what will happen? This will carbonize, and then this will elongate, and then a structure known as string may happen here, ultimately leading to the complete breakdown. So PD means partial discharge. It is not a complete breakdown of the insulation. Breakdown in the inside small void only. It will survive for a longer time, of course, even even for the lifetime also sometime. If the void sizes are very small. So since these are not breaking the insulation completely, these discharges are known as partial discharges, or this breakdown is partial breakdown only. So these dry type insulations have to be assessed using these three parameters, that is the electric strength, insulation resistance, and partial discharges. Now, prediction of life exactly for having operated in given temperature is very difficult actually. But certain guidelines have been developed over a period of time because we have experience of using transformer for a long time. So incidentally, the dielectric strength of insulation immersed in oil does not deteriorate until the material becomes brittle and cracked. So until that time, it does not deteriorate. The reason is due to oil impregnation and barrier effect. So why it is happening like this? Because you are impregnating the insulation with oil. So oil is also inside the paper. So for example, paper is there and you have immersed in oil. So when you immersed in oil, entire paper is actually wherever gaps are there, surface irregularities there, wherever that problems are there this oil is filled actually. Impregnated means with forcefully you are filling it. Since oil is filled like that, so the weak points of paper are already gone. So the paper, even if it is brittle, just supporting mechanically, even until that time, the breakdown strength will not deteriorate because oil will support the breakdown strength actually. So that is what is going to happen in case of oil insulation, class A insulation immersed in oil. So that is why its dielectric strength does not decay over a period of time, but it will happen like this. So here, whenever it failed, so it must have failed due to mechanical reasons. That is the problem. That is what it is observed experimentally. So it is possible, therefore, for a transformer to continue to operate long after the mechanical life of insulation is virtually used up, unless there is a disturbance, to the mechanical structure of the insulation. So it will go on surviving because oil is there already. So this is what is there, unless it is subjected to excessive mechanical stresses. When it will happen excessive mechanical stresses? They will happen during short circuit or even handling of the transformer. Suppose you are shifting the transformer from some place to other place, but of course it is not possible to shift a power transformer. I am talking about distribution transformers. So in that case, while handling also there may be some damage or any other mechanical shock. There may be the insulation which is already brittle might have succumbed to that one. But until that time, the electrical strength will be there due to oil which is impregnated into the solid insulation or of class A type. So this is what is the observation. Then usually it is oscillatory electrodynamic force during a short circuit which causes the disintegration of the insulating material, followed by a breakdown between the turns or coils. This is how a transformer fails. Transformer fails due to lack of mechanical strength or due to this oscillatory electrodynamic force which is happening due to short circuit which causes the disintegration of the insulating material, and that leads to a breakdown either between the turns or between the coils. And then the next topic is results of aging investigations. This topic tomorrow also we will continue actually, but I will introduce a little bit. So results of aging investigation suggest that rate of aging based on tensile strength actually doubles for each 5 to 10 degree rise in temperature. Please remember, it is not the aging itself, but it is rate of aging. This term you have to remember. Rate of aging doubles. For every 5 to 10 degree centigrade rise, between 5 to 10. 5 to 10 means some temperature. Within 5 to 10, particular temperature you have to understand based on tensile strength. For different materials, of course, even in the material, for example, paper, different manufacturers will have different papers actually. So each will have different aging characteristics. Some may double its rate of aging for 5 degrees centigrade, some may at 10 degrees centigrade, something like that. So based on tensile strength, it is 5 to 10 degrees centigrade, which will cause the double the rate of aging. And then Singer, a scientist, suggested 8-degree rule. He suggested that for every 80 degrees, the rate of aging will double. And then based on degree of polymerization, which is about 1300 for DP, which is called DP, degree of polymerization. We will study in detail later. 1300 for new, and for aged around 150 to 300. So then based on this parameter, if the aging doubles for 5.5 degrees centigrade rise in temperature. So then again the 1961 SIGRE working group, it has given 6-degree rule for taking the rate of aging as double for every 6-degree rule. So these rules have come up over a period of investigation by several scientists, several research papers. So of course, in industrial practice, it depends on the customer also to estimate the aging and all. So we will continue this topic tomorrow. So if you have any questions, let me know.
Sir, how fast can we get the recorded lecture, because the connection was lost for me. Actually, my internet gave up for like
all lectures you will get. Only I have to edit unwanted portions and all. That is taking time actually.
Oh, okay, okay, sir.
For example, there was some breakdown of internet here also. There was some gaps here also. And from your side also, there was some blur images. So I had to a little bit see, and every lecture you will get.
Okay.
Sir, I had confusion on yesterday's lecture.
Yeah.
During directed cooling, do you realize it in external cooling system?
External cooling system also you can use. For example, fans may be directed to radiator. These things are axially, or it depends, of course.
But they are forced.
That is mostly used for internal setup, because it is very sensitive inside how the oil will flow, in which direction oil will flow, whether it is flowing through the through outside the high voltage winding, or in between also, whether there are pipes which are directing the flow of the oil. So that actually the temperature throughout the length can be, throughout the height can be uniformly maintained, something like that. So these details of this flow, etc., we will study in next few classes actually, in detail.
Okay, sir.
So if there are no questions, so I will close this presentation. Okay. You may ask anytime.